section 4.1 part 3, and we're now looking at the form of a quadratic equation with y equals ax squared, and now we're going to add a plus c. Alright, so first we added an a in front of the x squared. Now we're adding a constant value, just a number. We're going to either add or subtract a number, so we'll see plus c. So how does this change things? Well, in the previous example, when it was simply just y equals ax squared, we said the value of our vertex was still 0, 0, just as the parent function. It's not the case anymore. This plus c will change where your vertex is located. How will it change it? Well, your x value is still 0, but your y value of your vertex will hold the value of this number, the c. So whatever this number is, that will be the value of your y vertex. So if it was 5, your vertex would be 0, 5. If it was negative 4, your vertex would be 0, negative 4. So let's take a look at our first problem down here, and we see y equals the opposite of x squared plus 2. So we have to populate this table, with values, and we know our vertex is going to go right in the center, as always. And we know the vertex holds the value 0, c. So x is going to be 0. What's the value of my c? Well, I see a plus 2. That's in the spot of plus c. So my c, or my y value, will be positive 2. And that comes from right here. So once I identified my vertex, I want to find increments going up maybe by 1 in this case in the positive direction, so I'll go up to 1 and 2. Then I want to go down to the negative direction, which is negative 1 and negative 2. And remember, these two numbers should be the same distance away from the vertex, as should these two numbers. So we see this is 2 units, this is 2 units. These two numbers are both 1 unit away from the vertex. So now we need to find the corresponding y values. So I'll start by plugging in x equals 1. So y equals the opposite of 1 squared plus 2. 1 squared is 1, so the opposite of 1 plus 2. And I get a y value of y equals negative 1 plus 2 is positive 1. Now I'll plug in x equals 2, so we see y equals the opposite of 2 squared plus 2. So it's the opposite of 4 plus 2. Negative 4 plus 2 is negative 2. So I found the two values to the right. Do I need to do the work to find the values to the left? Well, if I see that these two values are evenly spaced, as we said in previous videos, these two values will be exactly the same. So if I found 1, I can assume the second is the same value. And if these are evenly spaced, which they are, they're both 2 units apart, these two values will be the same. So since this value is negative 2, this value will also be negative 2. And now I can plot these 5 points, and I will basically have my parabola. So I'm going to start by plotting the vertex of 0, 2. Then I go to 1, 1. Then 2, negative 2. Then I'll go over to the other side of the vertex and plot negative 1, 1. And negative 2, negative 2. Connect these points with a smooth curve, and we get our parabola. We'll still want to label our axis of symmetry, that imaginary line which passes through the vertex. So we see our axis of symmetry is here. And it holds an x value of what? Remember, the axis of symmetry holds the x value of the vertex, which is x equals 0. Now, we also have a max or a min. This parabola opens down so it's going to extend forever in the negative direction, but it reaches a maximum height. It doesn't get beyond this point. So since it opens down, we're going to have a maximum value. So whenever our parabola opens down, we'll have a maximum value. Whenever our parabola opens up, we'll have a minimum value. And remember, the max or min is the y value of your vertex. The highest it gets is positive 2 on the y-axis. So just as we labeled up in the previous problem, I said if a is positive, the parabola opens up. In this case, we see our a is negative, so I will write if a is negative, your parabola opens down. And that will always be the case. So if this leading coefficient here, this first number in front of the x squared is negative, automatically you know your parabola will open down. Alright, that's the end of this section. Or this part, sorry.